Welcome to Scarlett. Scarlett, which stands for Scalable and Reconfigurable Electronics Platforms and Tools, is an EC-funded FP7 First Call project coordinated by Thales Avionics. This presentation will provide you with a general overview of how IMA2G platform can be handled thanks to dedicated platform services. Starting from IMA first generation, introduction of platform level services concepts will be introduced to match IMA second generation concerns to finally present expected benefits. What are platform services? Platform services are a concept that can benefit to various IMA stakeholders depending on their need in industrial or operational phase. First category of platform services are provided to avionic applications through application programming interfaces, for instance, but not limited to ARINC 653 Apex interface. These services handle classical programming topics such as scheduling, memory management, communication, time management, health monitoring, but also more specific resources such as mass memory facilities or graphical resources. Avionic operators also need services to operate the platform itself in operation or maintenance phase. These services allows for maintenance, data load and configuration in the large through dedicated programming interface and communication protocols. IMA2G platform needs also introspection service to monitor its own resource for safety purposes. Finally, extra services are needed during the whole IMA platform lifecycle, from supply chain to repair facilities to manufacture, integrate, test, troubleshoot and repair any platform component. In IMA first generation, services are limited to module. Basically, applications hosted on one module can invoke local services whose scope is limited to that module. IMA second generation brings the platform concept that is a collection or interconnected module thanks to the network. Applications are spread across all modules. This new architecture leads to the introduction of new platform services to provide hardware abstraction and ensure multi-module coherency. Applications may now invoke services with a platform-wide scope capable of addressing resources located on multiple local or distant modules. Scarlett project focuses on platform-level services. When looking at IMA2G platform architecture, we can see that it's made of several modules of possibly various kinds. In terms of services, it leads to module services that may vary across modules of different types, for example, ARINC 653, API, and POSIX API. Therefore, one of Scarlett's goals is to design platform services to cope with this module variability while offering homogeneous platform level whatever the module. While application developers may still invoke module-level services, they are provided with homogeneous common platform services whose behavior is constant whatever the hosting module. I propose now to look into the transition from IMA1G to IMA2G with a platform services perspective. The starting point is the architecture of a typical IMA1G module as depicted on this slide. From bottom to top, one can find module hardware resources, module basic software traditionally made of an operating system on top of a hardware support layer, along with an extra built-in internal services dedicated to module management. This software stack exposes services through an application programming interface or API. Typical API for safety critical IMA is ARINC 653 Apex interface. Other type of non-critical module may provide alternate API such as POSIX interface. Then, on top of this software stack, Avionics applications may invoke these module services via classical API calls. The picture is not complete yet. For both safety and operational reasons, the module needs special applications called system partition, in charge of module management activities such as module health monitoring, data loading and fault management. Since these features require advanced control of hardware resource, an extra privileged programming interface called MMPI is supplied, restricted to system partitions. From this picture, let's start the transition to IMA2G, limiting first the perspective to this sole module. First of all, let's give room for upcoming concepts. Application is moving up. Module services to the left. To introduce a new platform services level made of two main parts. First of all, platform services to serve avionic applications, and then a new kind of system partition called platform system partition, in charge of managing IMA2G platform, invoking platform management services, built on top of optional complementary hardware resources. This software layer is isolated from existing IMA1G architecture. However, it is designed to use existing module services thanks to both API Application Program Interface and Module Management API. In its turn, this software layer exposes its services through two programming interfaces, as in IMA1G architecture. The first interface encompasses all services accessible to all applications and system partitions. It's called PAPI, as Platform Level Application Programming Interface. The second one is called PMPI, as Platform Management Programming Interface. It provides specialized, privileged services to a new kind of application called Platform Applications, in charge of integrated management of the whole IMA2G platform, such as platform fault management or reconfiguration. The animation is complete. This is a typical architecture of a module belonging to an IMA2G platform. The green parts encompass module services that originate an IMA1G. Orange part encompass platform services brought by IMA2G as a complement of IMA1G. At that point, it is important to note two properties. Platform services provide a greater abstraction, however they are not mandatory. Applications can still invoke module-level services. Platform services availability may vary across modules belonging to the same platform. For instance, platform applications may be deployed only on a limited set of modules, thus not requiring PMPI everywhere. To better understand, let's move to the big picture. Here comes the big picture, where each column describes one module. Platform-level programming interfaces are continuously provided to application levels, whereas module-level services are limited and specific to each module. As an example, 3 platform management applications located on the first 3 modules can take benefits of platform services to rule the whole platform. Other applications, drawn in yellow, can still invoke module-level services with possible access to platform-level services. Now that we have structured the concepts, let's go forward on a functional classification. Services Foundations deals with core software features, management of communications, time, memory and process and partition scheduling. Other group of services deals with the platform health status, configuration and setup. Additionally, more specific services can handle dedicated resources such as graphic or mass memory resources. Finally, observability and configurations built-in services enable platform development and operation during all industrial and operational life cycle. As previously exposed, all these functions can still be grouped either by privilege level. On the left, services for applications. On the right, services for platform management having more privileged access. Or grouped by scope. In green, module level. In orange, platform level. Let's take two examples. Graphical services are usually module level since they manage only dedicated resources attached to the module the application resides on. File management is definitely considered at platform level in Scarlet Project. File services can be accessed from anywhere, whatever the location of the mass storage. How to access platform services? The first way is from an avionic application. Several programming interfaces are available. The second way is from a platform management application that can invoke privileged programming interfaces in addition to classical avionic ones. Tools can also remotely invoke services such as data load and observation. To summarize, not only the services are invocable from different actors, but they are globally coherent, preventing any undesired side effects thanks to a firm IMA2G segregating foundation. At that point of the presentation, given a set of services, we might face a situation where both module level and platform level services are available. So how to decide which is the best one for one's given application? Let's take a look at two opposite solutions. Back to IMA2G, the classical way for an application point of view to access a remote resource is attached to a different module is to develop a proxy application located on the remote module and to have its relay request issued by demanding application. Application concerns in terms of integration are focused on the development and the validation of a communication protocol. In IMA2G, while the first solution is still relevant, platform services can help a lot by providing pre-integrated, distributed services taking care of the communication protocol. The situation is much simpler for the demanding application that can just invoke resource access through a classical API. By promoting a move from a protocol paradigm to an API paradigm, IMA2G can simplify application suppliers' life. To conclude this presentation, I would like to highlight key points regarding this new platform service concept based on IMA2G to IMA2G comparison. At module level, one can see that IMA2G software architecture is compatible with IMA2G. The key point is that IMA2G kept unchanged. IMA2G additional components made of software libraries and system partitions are built on top of IMA2G module services. This leads also to an interesting property for system designers who can now better distribute and specialize system partition involving resource management by clearly separate management at module level and management at platform level. Enlarging the comparison at platform level, here is the big picture with the whole platform drawn in third dimension. On the left, the architecture shows a collection of IMA2G modules with no evidence of platform-wide integrated services. Exchanges between several modules are likely to be handled by the numerous system partitions at module level. On the right, the introduction of platform service in orange can help rebalancing the whole software layout across the platform. Expected benefits are: first, the function suppliers to reduce software development effort by replacing technical code in charge of multi-module protocol communication with platform services capable of handling the distributed architecture aspects. Then for the system designer to be able to implement easily a managing application that is capable of monitoring and controlling the whole platform thanks to a higher level privileged programming interface. These applications can be hosted on any module, thus freeing the system designer from the burden of a low-level programming to cope with the IMA2G complex distributed architecture. Thank you for listening. We hope this presentation gave you a better understanding of the platform services concept and how it can benefit to IMA2G stakeholders. Special reference should be given to other Scarlett partners involved in the work presented as Airbus UK, Skysoft GmbH and Cisco. Please visit our website, and should you have any further questions regarding this presentation video, please do not hesitate to contact any of the persons mentioned. Thank you for your attention.